So in our third video of Unit 3, we're going to take some time to now analyze the graphs of functions. So what interval is it increasing, decreasing, and staying consistent, being able to kind of give a story behind a graph, and then also identifying the independent and the dependent variables. So let's first start with increasing. So simply put, it is the interval in which the graph is or has, I'm going to cross out is, has a positive slope. So it's going up. And then decreasing is the interval in which the graph's slope is negative. Okay, and so an example of what that might look like. So if I've got a graph and let's say it looks something like this. It's going up and then flat and then down. Okay, so I'm going to zoom up on that. So this would be my increasing right here, right? It's positive. So I'd say that's increasing here. Then it is staying constant right here. And then here my slope is negative and therefore is decreasing. Okay. So zooming out of that, then we also have what's called the dependent variable and the independent variable. So I say that a dependent variable is affected or changed, so affected by your independent. And this always lies on the y-axis. Okay, because the y-axis in a way literally depends on the x. And then the x-axis is your independent variable. So it affects, it's the one doing the changing, the dependent. Kind of running out of room there. Okay, and so again, that is the x-axis. So we're actually going to take some time just to identify the difference in situations between what's the independent and the dependent. So looking below here, okay, so in number 1 it says, okay, we've got the air pressure inside a tire increases with temperature. So is the temperature affecting the air pressure or is the air pressure affecting the temperature? Okay, that's usually the questions that I'll ask myself. So I would say that the air pressure is being affected by the temperature. So the tire pressure is the dependent. And then the temperature is the independent. The number 2, generally the average price of going to the movies has steadily increased over time. So ask yourself, is the price of going to see a movie affecting time, or is time affecting the cost of going to the movies? And so because time is doing the changing, time is your independent. Independent. And then your movie ticket price is the dependent. It literally depends on, like, what time. Even like in today, like you can go early at an early movie time, it's cheaper, and if you go later, it's more expensive. So try number 3 and 4 on your own. So number 3 says the more tickets sold to homecoming, the more student council can spend for decorations. Okay, so the number of tickets sold affects how much money I can spend on decorations, right? So it's doing the changing, I guess you could say. So the number of tickets sold is the independent. And then the money for decorations is literally depends on how many tickets you sell. And then number 4, it says as the amount of rain decreases, so does the water level of the river. So does the water level affect the amount of rain? No, the water level literally depends on the amount of rain. Okie dokie. All right, so let's go on to the next page. So on our next page, we're going to look at identifying where is my graph increase, where is it decreasing, and if there's any constant. Okay, so first of all, we always read a graph from left to right. That's important to know, left to right. So looking at number 5, when I'm looking at this graph, I'm kind of reading it from here to there. Okay, and so I see them from right here. Now, notice how this has an arrow. So that means it goes on forever. That's important to know. And then I see it's decreasing and up until it hits 4. So my interval for decreasing would be, okay, from negative infinity, since it goes on forever, to, I'd say about 3.9, or you could say 4. And then it is increasing from 4 to positive infinity. Okay, so just, again, I'm using infinity because it has an arrow. That means it goes on forever. So then looking at number 6, I have multiple intervals in which my graph is increasing, right? So I see it's increasing from right here to here, but then also from 4 on. So the way I would write that is it is increasing at an interval between 0 and 2. And if you're wondering where I'm getting that number, okay, so a graph starts here. So that's when x is 0. And then it stops increasing when x is 2, right? And then it starts increasing again when x is 4 on until infinity. So then I would write that as I also have, okay, an interval at 4 on to infinity. So now I want to find where is it decreasing. And I see that that's decreasing right here from this point where x is 2 up until where x is 4. And so that would be my interval for decreasing. I would say from 2 to 4. Okay, so then let's also look at how do we kind of tell a story from a graph? How do we kind of make a story by looking at a graph, I guess you could say. So the directions say that Tom skateboards all around town. He was at home and then he decided he wanted to go to skateboard to the park and back. The following graph represents Tom's journey to the park and back home. So part A just says label the graph where Tom starts his trip. So he would start right here, right? His time is 0 and his distance from home is 0. So this is where we would say we start. Then label on the graph where the park is. Well, how will we figure out where the park is? He's obviously skateboarding to the park and then he's coming back home. So I want to find the part in the graph where he's the furthest from home, right? Because that would be the park, and that would be right here. And so let's see, this is the park. And part B is also asking us, well, how far away is it? So looking at, let's see, here's my point. You can maybe make the argument that it's, I don't know, about 4 miles. No, that would be 3.5 actually, because the graph's going up by half. See, half, then 1, 1.5, 2, 2.5, 3. So I'd say it's about 3.5 miles away. And then part C says, how long approximately does it take Tom to get to the park? Okay, so if this is the park, right? What I would do is kind of drag my finger down, and we're kind of approximating here. So it's between 35 and 40 minutes, maybe closer to the 40 minutes, so maybe I'll say 38 minutes. So approximately 38 minutes. It's pretty good. And then approximately how long does it take Tom to get back home? So I would say, okay, so if we're at 39 minutes right here, 38, and then he's getting back around, I don't know, at 61, a total of 61 minutes away from that it took for him to go to the park and home. But I want to actually find that difference, right? Because if he leaves at this point here, okay, and then he's getting home right here, I would say that that's approximately 25 to 28 minutes it took him. So approximately 25 to 28 minutes, depending on how you look at the graph, okay? But that I would say is a safe window of time to approximate. So flipping over to our last page of notes for this video, looking at number 8, choose the graph that best describes or represents each situation. So I've got situation A, a tomato plant grows taller at a steady pace. That's all that they're telling me. So I would go with graph C, okay? Because over time it is consistently growing. B says a tomato plant grows quickly at first and then remains at a constant height. So that's a kind of a keyword, constant. So I'm looking for a flat part in my graph. And then it grows at a steady pace. So I would say that that's B, right? Plant grows quickly, so boom, it increases, very steep slope. Then it's consistent, and then it starts to grow again. And then C, a tomato plant grows at a slow pace, then grows rapidly. So let's see, I would say it grows slow, that would be A, and then rapidly. And then finally, number 9, which situation best represents the graph? So look, we're looking at time versus temperature. So A says that the temperature increases, and I'm just going to kind of draw this, like what would I picture? So the temperature increases, then decreases, then increases rapidly. I wouldn't say that that's true. All right, so let's see. B, here's my visual of that. So the temperature stays constant. Then, sorry, that's a terrible straight line. Let's try that again. So it stays constant, then increases, then stays constant. No, not quite. So I wouldn't say that B is a good option. Let's look at C. So my visual of C would be that the temperature decreases, then stays constant, then decreases rapidly. Ooh, that would actually be probably a steeper slope. Probably too straight down. And then, so I would say C is not a good option. So then D, the temperature increases and then stays constant, then increases rapidly. Yes, I definitely would say that D is my best answer.